Thank you so much. I really appreciate the opportunity to be here and the invitation. So yeah, I'll be sharing just a portion of my PhD dissertation with you, and of course want to acknowledge my co-authors who have been really instrumental in this work. What I'm going to talk about today is some sort of preliminary results regarding an overall framework and how we might select locations for conifer removal that can help us balance some of the trade-offs between these sagebrush-associated species and the Pinyon-Juniper-associated species. So you've heard a fair bit this morning, and I think a little bit yesterday, about the management issue that's happening here in terms of trying to manage for sage grouse. We have conifers that are kind of coming into areas that had, at least in the last few decades, sort of historically been sagebrush habitats. Obviously, we need to do a lot to restore sagebrush. And so an increasingly common treatment that I think probably a lot of people in this room are more familiar with than I am is to go in and do some mechanical treatments in these areas. And there's a growing body of evidence, and this is far from all of it. This is a very small subset of what's come out in the last, well, since 2013. There's kind of a seminal paper, but there's a lot of positive impacts to sage grouse in terms of nesting, habitat suitability, brood rearing success can all be bolstered by these conifer removal treatments. But one thing that we don't know as much about, although Pat's done some cool work, is some of these potential trade-offs that we would have with sagebrush species and then some of the Pinyon-Juniper associated species. So, we would expect, and some people have found some evidence that some of those sagebrush species are likely to benefit from these conifer removal treatments. There's a handful of these generalist species kind of in the second row there, which may be mildly impacted one way or another by these treatments. And then we would stand to reason that these Pinyon-Juniper associated species may be negatively influenced by these treatments. And then Amy just did a great job of highlighting the Pinyon Jay and the proposal for listing. And so it's a species of increasing conservation concern. She showed you the graph of the population decline, which is really in the same magnitude as what we're seeing with greater sage grouse. So this is probably a species that needs to be on our radar. So in order to try to balance these trade-offs, we really needed, as a first step, to get a better sense of what sorts of resource conditions on the landscape are going to lead to high densities of these species. And so what we did is we used a bunch of remotely sensed layers as explanatory variables. We used breeding season point count data, and then develop these abundance habitat relationships using a hierarchical Bayesian modeling approach. Accounts for incomplete detection, and we think is pretty robust. And then what we can do is we can take the current conditions on the landscape and we can use those relationships and then predict bird abundance across the landscape. And so I'm showing this here for Pinyon Jay, but we've done this for those 11 other species that I showed in the last slide as well. And then for the rest of the talk, I'm gonna focus on this little red square that you see in southern Utah. The square is about a 60 mile by 60 mile location. And I'm also switching up on you here, and I'm switching from Pinyon Jay over to sage thrasher. And so here's, this right now doesn't look like a great habitat for sage thrasher. We see pretty low abundances shown in purple. The light blue indicate slightly higher predicted abundances. And what we can do is we can just simulate conifer removal across the landscape simply by setting the proportion of Pinyon-Juniper cover that is in the model down to 0. And then we can re-predict the abundance given those conditions with this change that we've made. And sage thrasher, surprise, surprise, is positively associated with sagebrush and negatively associated with Pinyon-Juniper in terms of abundance and densities. And so once we conduct and simulate this conifer removal, we see that we can would expect much higher densities of these sage thrashers on the landscape. And then what we're really interested in is, well, what are we getting out of this? If we were going to cut, what's the outcome? So we take this simulated, predicted abundance under a removal scenario, and then we can subtract the abundance given what we think the current conditions are based on those remotely sensed layers. And then we get sort of this change in density. And I'm going to show you a handful of these maps, and I just want to let you know that all of them, the warm areas are areas where you're getting sort of high conservation value. So for the sagebrush species, you're getting increases, and for the Pinyon-Juniper associated species, you're getting low declines in abundance. So yeah, warm area is good. Okay, so the optimization procedure that we're using, one of the things that you need to feed in there is sort of planning units is the terminology. And so basically we were willing to entertain conducting conifer removal on any location that had conifer according to Landfire 2016 data. So we made a binary layer of existing vegetation types, classified it as Pinyon-Juniper or non-Pinyon-Juniper. The Pinyon-Juniper is the dark green, the bright green, and the whiter areas are the non-PJ habitat. And then you also want to set targets. So whether it's population level targets or amount of area to be treated. And so we arbitrarily chose as a first crack at this, that managers might want to reduce the amount of Pinyon-Juniper habitat in these kind of sagebrush interfaces by 10%. So that's the target there. And then specifically, we use this linear integer programming to try to find an optimal solution. We used a package called Prioritizer in R. Okay, so I'm going to walk you through a couple of these different sort of problem sets that we ran, and we're going to sort of build complexity as we go. So we'll start out with a single species optimization, and I think we're all pretty well aware that historic land management paradigm was sort of single species focused. And so if we're narrow-minded thinking about sage thrashers, which very few people do, but I like them, we're going to feed in this change in density, we're going to feed in the Pinyon-Juniper layer, and we can solve for this. And so here again, the bright green are areas that were selected for conifer removal from this optimization procedure. I don't know how well you can see that, but the white areas are areas that don't have Pinyon-Juniper, and then the lighter green are areas that do have PJ but weren't selected in the optimization procedure. Okay, so that's all well and good. Well, let's try to build in some more species and shift from a single species management paradigm to a multi-species management paradigm, which is what I'm hearing a lot of people are talking about, kind of managing for the overall sagebrush health. And so we can bring in a couple of other sagebrush species, including sagebrush sparrow and green-tailed towhee, and we get a slightly different but pretty similar solution, and I'll show all of them together here in a minute, so you can see differences. But really what I'm interested in trying to move towards is sort of a multi-ecosystem management approach. So not single species, not single ecosystem, but multiple ecosystems so we can really balance these trade-offs. So we're going to bring in 3 Pinyon-Juniper associated species. These are Buick's wren, Pinyon jay, and juniper titmouse. You notice the maps look a little different. Again, the color ramps are all the same. So the red areas, warm areas, are areas where we're getting sort of good conservation value for that species if we conduct conifer removal, and the blue areas are not so good. So again, the 3 species on the bottom, our modeled abundance relationships show that you'd expect lower densities where when you remove conifer. And so you have lots of red areas where basically these species aren't occurring. You're getting no real loss by removing conifer from those locations. And then the blue areas are areas where we're expecting high densities and we would lose individuals if we were to conduct conifer removal at that location. Okay, so here's the solutions for these 3 different problems. With the single species on the left, the 3 sagebrush species in the middle, and then the 6 species sagebrush and PJ combination on the right. And in the circled area here, you can see there's some similar sites that are being selected across all of these. But then you also see that there's some differences. So this circled area, it was selected to receive conifer removal in the 2 left maps, but then once we start thinking about the Pinyon-Juniper species, maybe we don't want to cut there. So then I'm, of course, interested in trying to quantify what is the real conservation outcomes from this. So we can take the solution layer, and this is the single species problem that we ran, but we can, we did this for all of them. And then we take that change map, this is the kind of expected change in abundance once we go ahead and remove the conifer, and we can just mask out all the areas that we're not going to treat and just look at where we treated, what are we going to get out of it. And we can do this for the other sagebrush species, and we can do it for the 3 Pinyon-Juniper species. And then we can sum these values. We can multiply it by the unit area of each raster pixel, and then we can come up with a number of individuals that we would expect to really be impacted by these treatments. So I'm going to walk you through this, and these are, again, number of individuals now, so we're moving away from density and into abundance. We're going to start with the one species optimization and look at those outcomes, and we'll move on. So we'd expect with the sage thrasher optimization model that we would get about 682 additional sage thrashers by treating this 10% of the PJ in this 60-mile by 60-mile region. And we get some nice benefits to some of the other sagebrush associated species as well. But then here's the scary part. Okay, so we can move on to the 3 species optimization, and we see that now once we're not just thinking about sage thrasher, but we're also thinking about green-tailed towhee and sagebrush sparrow, that the sage thrasher doesn't benefit quite as much. Sage thrasher and sagebrush sparrow and green-tailed towhee do a little bit better, and we're still seeing some pretty big negative impacts to these Pinyon-Juniper species. And then we can look at this final problem that we ran with 6 species. And we see that again, the sage thrashers, it's not doing quite as well, but we can really mitigate some of these negative impacts to the Pinyon-Juniper species. And I know looking at big numbers can be a little bit abstract. So what I did is I summed up the total number of existing individuals given current conditions on the landscape. And then we just turn these numbers into proportional or percentage changes in the population for this region. And that's shown here. So again, for the sage thrasher, as we go from just thinking about sage thrasher to thinking about sagebrush species to thinking about sagebrush and PJ species, we see that they don't get quite as good of benefits, right? But we can also mitigate a lot of these losses to Pinyon-Juniper species. So we're going from losing 15% of the whole juniper titmouse population in this region down to just losing 5%. And interestingly, you've got the sagebrush sparrow that even does better when you think about the PJ species than sagebrush. I think that's a bit of an anomaly in this situation because of our test case, but still kind of interesting that there's not a lot of sacrifice for that species. So in conclusion, we're working on this optimization framework. It's in a very kind of preliminary stage. We'll be finishing it up over the next couple of months, but we think that this framework can really help mitigate some of these negative impacts. And again, as Amy mentioned, this is going to be an increasing need to think about Pinyon Jay as we're doing these treatments. And then, looking at these sort of scary negative numbers, I think the results sort of demonstrate that there really is kind of an importance in considering these trade-offs to non-target species. And I just want to point out that, these are some toy examples, kind of high level to demonstrate, but we're going to be adding a lot more complexity. You can change the species, you can weight species differently in these optimization frameworks. So you can say, we really don't want problems with Pinyon Jay. Maybe we don't care about juniper titmouse or whatever, and you can kind of make some adjustments to the species that you consider. You can set, of course, different treatment amounts. We can consider only planting units within greater sage-grouse core areas. There's a lot of different ways that we can kind of fine-tune this tool. And then also of interest is including costs. Right now we're looking at using the proportion of Pinyon-Juniper habitat within a certain region as sort of a surrogate for cost because we don't have a lot of great cost data on these treatments. I'm excited about Leaf's tool, and I want more than 15 records. And if you guys have that information, I would love to get some to maybe play around with trying to incorporate that as well. There's another cool feature of this framework, which allows you to incorporate a boundary cost, which basically prevents the solution from being extremely fragmented, which I think could be important for logistics on the ground. You're not going to want to go drive and hike, and do all the paperwork to cut 3 trees. And then lastly, hopefully the sort of conservation planning utility of this, and for gunnis and sage grouse as well as greater sage grouse, is fairly obvious. But I think also in terms of generating support for the projects and also fine-tuning and using some quantifiable data in your environmental impact assessments could be useful as well. And with that, I just want to thank my PhD committee. Cam is my advisor, so he's not listed there. He's an author instead. And then, of course, great contributions from colleagues at CSU and USGS. And all the habitat abundance models were informed by the Integrated Monitoring and Bird Conservation Regions program. We used computing resources at USGS, a whole suite of remotely sensed data products. And of course, it's all made possible from the funders. So with that, I don't know. I wanted to include my email. Please reach out. We still have time to fiddle with this before I finish my dissertation. Act quickly though, please, and hit me up soon. So thank you very much.
I have a question online. You referenced treating 10% Pinyon-Juniper. Is this model assuming treating PJ forest areas across the landscape, or 10% of only phase 1 or 2 encroaching?
So I'm still in search of a great Pinyon-Juniper phase layer. So we've toyed with the idea of trying to use the amount of sagebrush understory as sort of a surrogate. Because as you move into phase 3 and phase 4 woodlands, you start to have less and less of a shrubland understory. So that's kind of where we're landing right now, is thinking about maybe setting some sort of a cutoff, because we do have pretty good sagebrush cover layers to use. But yet right now we're not explicitly looking at phase 1 and phase 2 as well as we could. So if anybody knows of any tools or layers, please again reach out.
Yeah, hey Nick, thanks over here. Yeah, thanks for the presentation. I think it's great to be really starting to explicitly incorporate some of these trade-offs as we move through these really, increasingly tricky conservation issues with, likely competing interests of pinyon jays and Gunnison sage grouse or greater sage grouse in the future. One question I had was, presumably these underlying habitat models have some degree of accuracy or error associated with those. And those errors are going to translate over into your estimates of percent, positive or negative change in these species. Do you have any sense on what, is that pinyon jays would decrease, let's say 4% under this scenario, plus or minus what?
Right, yeah. I love that question. Thank you for asking it. And actually, we had a whole lab-wide discussion just last week. Cam's laughing about this. And so we've been made aware of a bunch of papers that have talked about how to incorporate uncertainty in these optimization procedures. I haven't had a chance. I've been prepping for this, so I'm not sure how suitable that will be. The one thing I can tell you is that all the species that we've done the relationship modeling for, if you think about the beta estimate of the population or density response to Pinyon-Juniper cover, they never overlap 0. So it is, and if you're talking about terms of numbers of birds, certainly there's going to be some error there. And I maybe I shouldn't have provided individuals or something. I think it's kind of compelling as a frame of reference, but in no way do I think that if we treated those spots that we would have 682 fewer pinyon jays in the area. But the thing that gives me some confidence is, because those the credible intervals for the relationship with Pinyon-Juniper habitat don't change, the magnitude, yes, can differ, but you're still moving in the right direction. And so, I think Seth once told me, he's like, I don't need to know the exact birds, just tell me if I'm doing the right thing or the wrong thing. And I think that that's how this model can maybe help.
Yeah, I guess it'd be interesting to know if you're doing the right thing or the wrong thing, to what degree you could be confident in that. And
yeah, so
50% of the time this is the right thing, maybe, right?
Yeah.
So I'm just suggesting that it'd be interesting to know a little bit about that.
I definitely
how much confidence we would have in those projections.
Yeah, for sure.
So thanks.
I agree with you, and we will be looking into it for sure. So thanks.